Hey everybody, today we're going to talk about domain and range of a function. When we refer to the domain, we're talking about the x values, or in other words, what you're going to input into the function. When we talk about the range, we're going to talk about the y values, or what you're going to get out of the function. Alright, so in this case, we have a set of points. To find our domain, we basically just have to list our x values. So if we remember, our x values come first in all of our coordinate points. So our domain is going to be 2, -2, -1, and 2 again, but we don't list it twice. So our domain is just 2, -2, and -1. And we always show the domain and range with brackets on each side. Our range is going to be our y values. So 3 again, but I already have it, so I don't list it again. 0 and 4. Make sure we put the brackets on both sides once again. Alright, when we're looking at a mapping diagram, we can also find the domain and range. Remember, domain is once again the x values, or what you input into the function. So in this case, our domain is going to be 2, -1, 0, and 3. Our range is just our y values, which is what you get out of the function. So 5, -1, and 2. Domain and range is very easy to find with a mapping diagram because they're already listed there right for you. Alright, and then the third way to find domain and range is by looking at a graph. So if we're looking at a graph, what we want to actually do is first find all the points of the coordinate points of our points on the graph. So looking at our first one here, we're going to have to go over 4. So our x value is 4. Our y value is 2 because we go up 2, 4, 2. So that means our first number in the domain is going to be a 4 because that's our x value, and our first number in the range is a 2 because that's our first y value. Okay, finding this point, we go over 1, so our x value is 1, and we don't go up or down at all, so our y value is 0, so 1, 0, which means our x value is 1, so another number in our domain is 1, another number in our range is 0. Looking at this point right here, we go left 2, so our x value is -2, and we go up 3, so our y value is 3. So we're going to add -2 to our domain and 3 to our range. Down here we go left 2, so -2 is our x value, and down 3, so -3 to our y value. Now our x value is -2, and we already listed -2 in our domain, so we don't need to list it again, but we're going to list -3 in our range this time. And our final point, we go left 5, so -5, and up 1, so -5, 1. So we list -5 in our domain, and we list 1 in our range. And we're completed. Put your brackets on the other side, and there's your domain and range. Alright, let's do one more example from a graph. Alright, starting with this point here, the coordinates of this point are going to be 5, 1 because we went right 5, up 1. So we're going to start by putting a 5 in our domain and a 1 in our range. This point is going to be over 2, up 3, so 2, 3. So we're going to add a 2 to our domain and a 3 to our range. this point we don't go left and right at all, so our x value is 0, and we go up 3, so 0, 3. We're going to add a 0 to our domain, and we already have a 3 in our range, so we're not going to put another one. This point we go left 2, so -2, 1, because we go up 1. We're going to put a -2 in our domain, and we already have a 1, so we're not going to add a 1 to our range. And then our final point, we go left 4, so -4, and then we don't go up or down at all, so -4, 0. So we're going to add a -4 to our domain, and we're going to add a 0 to our range. And we are done. So our domain is 5, 2, 0, -2, -4, and our range is 1, 3, and 0. Alright, and finally we want to find the range for 2x plus 1 if the domain is 2, 3, 0, -1. Now this f of x is just a fancy way of saying that it's a function 2x plus 1, and that you can input stuff into that function for x right here. Okay, once again the domain is our x values. So what we're going to do is basically just replace x in the function and see what we come up with. So you have 2x plus 1 that you're going to replace the x with. So our first one, we have 2 times 2 plus 1, which is going to give me 2 times 2 is 4, plus 1 gives you 5. My next one that I'm going to plug in is a 3, so I'm going to take 2 times 3 plus 1. 2 times 3 is 6, plus 1 gives you 7. My next value is a 0, so I'm going to take 2 times 0 plus 1. 2 times 0 is 0, plus 1 gives you 1. My next value is a -1, so 2 times -1 plus 1. 2 times -1 is -2, plus 1 gives you -1. So my domain is 2, 3, 0, -1, but my range is 5, 7, 1, -1. Okay, so all we did was plug in our x values into our function to be able to come up with our range. Alright, here's another example. Our function is 1/2 x plus 2, and our x values, or our domain, is 0, -2, 4, -6. Okay, so when we plug it in, we're going to plug into 1/2 x plus 2 is the function that we want to actually plug into. So our first value is 0, so we're going to say 1/2 times 0 plus 2. Well, 1/2 times 0 is just 0, plus 2 is going to give you 2. Our next value is -2, so 1/2 times -2 plus 2. Now you can be using a calculator for this. If you wanted to plug it into a calculator, you would just use 0.5 for 1/2. Or you could take -2 divided by 2, or take 1/2 of -2, which is -1 plus 2 gives you 1. Our next one is 4, so we're going to take 1/2 times 4 plus 2. Well, 1/2 times 4 is the same as a half of 4, or 4 divided by 2, which is 2, plus 2 gives you 4. And your final value is negative 6, so 1/2 times negative 6 plus 2. 1/2 times negative 6 is the same as negative 6 divided by 2, or 1/2 of negative 6, which is negative 3, plus 2 gives you negative 1. So your range for this problem is 2, 1, 4, negative 1. Once again, all we did was look at our original problem, 1/2 x plus 2, and we plugged in our x values into the problem. All right, and our last problem that we're going to do. We have 1/3 x, 1/3 x plus 2, and our x values are negative 3, 0, 1, and 7, because that's the domain. So we have the function 1/3 x plus 2 that we want to plug our values into. So my first value is negative 3, so I'm going to take 1/3 times negative 3 plus 2. Well, 1/3 times negative 3 is the same as negative 3 divided by 3, or 1/3 of negative 3, which is negative 1, plus 2 gives you 1. Our next value is 0. 1/3 times 0 plus 2. 1/3 times 0 is 0, plus 2 gives you 2. My next value is 1. So I'm going to take 1/3 times 1 plus 2. Well, anything times 1 is just itself, so 1/3 plus 2. Well, remember, in order to add fractions, they need to have a common denominator. So 2 is the same as 2 over 1. And in order to make the denominator the same, we need to multiply by 3. So that gives me 1/3 plus 2 times 3 is 6 over 3. So 1/3 plus 6 over 3 gives you 7 over 3. So far I have 1, 2, and 7/3 as my range. My last value is 7 that I'm going to plug in. So 1/3 times 7 plus 2 is going to give you 1/3 times 7 is just 7 over 3 plus 2. Well, in order to make, we need to have a common denominator again. So this is the same as just 7/3 plus, we already determined from the previous one that 2 is the same as 6/3. 7/3 plus 6/3 gives you 13/3. All right, so your range is going to be 1, 2, 7 over 3, 13 over 3. Remember, we can multiply fractions, we can add fractions. We just need to know how, we just need to remember when we're adding to have a common denominator. And when we multiply them, it's the same as taking, for instance, 7 divided by 3. All right, and that is how we find domain and range of functions. For tomorrow, bring to class finding the domain and range of this set of points. 0, 2, 3, 4, 8, 4, and 1, 3. Just bring me the domain and range of that set of points. And we will see you tomorrow.